The slow in and slow out principle, or easy in, easy out, is so important but also really easy to understand and put in practice. The concept is, an object doesn't have a constant speed during a movement, it will have an acceleration at the beginning and a deceleration at the end. So we'll start slower, slow in, increase the speed in between, and end slower before to stop. To add the slow in and slow out to our movement, we need to change the spacing of the in-betweens at the start and the end. If we have an object that moves from A to B and the tangent is linear, so we don't have any variation in the speed, we would have a stiff and mechanical movement. If we have the same movement but we change the position of the in-betweens near the first key pose and the last one, the movement results more soft, smooth and realistic. Try to recreate a movement yourself. Move your arm from A to B. You should perceive that your arm needs a bit of time to reach the speed, and then when you stop it, it slows down. Always remember that we are doing cartoons, so to have a more appealing animation, we can even exaggerate this principle. This doesn't mean that you have to increase the timing of your animation to have more in-betweens at the start and the end. It's always based on the speed of your action. In a faster action, you will have few frames, but you will still can manage them in order to have a slow in and slow out effect. Using the graph editor is very easy to achieve the result we need. Using a flat tangents, we already have a smoothness on the extremes. If we use the spline tangents, we can reach the same result using the handles. We can also add an in-between near the first pose and another one near the final pose, and move them on a value closer to the extremes, until you don't reach your desired effect. But keep attention when you adjust the handles to don't create this type of curve where it goes on a higher or lower value compared to the last pose value, otherwise you will have a backward or forward movement. So in this case, for example, the ball is moving forward, but in the part between the in-between key and your extreme key, the curve overtakes this value. So the ball would go forward and then backward to the extreme position. So this don't mean that this is wrong, but if you just want to use a slow out, so you just want to smooth the movement forward, keep attention to don't overtake this line. A pendulum clock is a perfect example of slow in and slow out. Look how smooth is the movement on the two extremes, slow, fast, slow. With the same key poses and timing, but with different spacing, we would have a linear movement that is really unrealistic. As you can see in the graph editor, I created a loop animation, so I have the two poses at the beginning and the end with the same position, and another extreme in the middle with the pendulum in the opposite direction. In this case, the tangent is linear. That's why we have these effects. The interpolation has a uniform velocity, so all the in-betweens have the same distance between each other. So just switching the same curve in flat, the spacing of the in-betweens change and the movement is more realistic. If we create the same movement with a character, the principle doesn't change. We will always have a movement that starts slow, takes speed and slow down again. So use this principle with all its variation for your object and character movements. It's really easy and quick to achieve, and your animation will change a lot. This principle is probably the one that characterizes most the cartoon animation. It's a phenomenon that we can see in real life, but the exaggeration of this principle makes the animation more cartoony, compared to a more realistic animation where this principle is less emphasized. The squash stretch is still there, but should be felt rather than seen. So it's a principle used in both the style, but in the cartoon animation is more extreme. The principal concept is, an object or a character changes its volume during the movement. It maintains its original volume, but this changes shape by stretching and squashing. When the squash stretch shouldn't be used. It will be unrealistic to change the shape of a stiff object. Rigid material doesn't deform, like a bowling ball or a robot. This type of objects don't change their shape even during an impact. How to determine the amount of squash and stretch that can be used? It depends on the object material, different levels of elasticity and flexibility, and the style of your animation. As I said, a more cartoon style allows to exaggerate the squash and stretch amount. So as we already have seen in a previous lesson, when we have an object like a ball, we can have a different amount of squash depending on the material, the force of the impact, and the weight. Here two examples of percentage of squash just based on the material. Starting from an object that would have an extreme and visible squash and stretch, like a balloon full of water, up to a stiff object that wouldn't deform at all. The human body is organic, composed by flexible muscles and rigid skeleton that doesn't allow us to change our shape too much. But as I always say, we're doing cartoons, so we can take inspiration from real life and add a bit of exaggeration to make everything more interesting and readable. Keep in mind, during the squash and stretch, the object or the character changes shape, but the volume remains constant. When we extend a part, we have to reduce another one. How to use it? In character animation, there are many situations where we can use this principle. Body mechanic movements like walks, runs, jumps, facial expressions, and acting with extreme poses to emphasize moods and reactions. Let's see some examples. During a walk or a run, we can squash and stretch the chest during the up and down, like the bouncing ball principle, but with a bit of delay. During a jump, the body squash in the preparation to the jump, then stretch during the push and when it lands. In facial animation, you can use this principle for takes, a fast change of expression, a quick reaction. During the take, the head squash in the breakdown between the two extremes, usually with closed eyes, and stretch for a few frames during the change of expression, and then go back to the default shapes. To make it more cartoony or to have a stronger reaction, you can keep the stretch shape for more frames. A soften squash and stretch can be used during a simple turn. The principle is the same, but the change of shape is very small. During the lip sync, when a character talks, the face muscle follows the jaw's movements. For example, in an M shapes, we squash a bit the head. During an O or A mouth shapes, we stretch a bit the head. During a blink, we can squash a bit the head when the eyes are closed. It always depends on how much you want to push the cartoony effect. In reality, when we blink, we don't squash the head. We also barely don't move the brows, but in cartoon this is allowed, and this kind of tricks makes the characters more alive. We can also use it to emphasize a moment, a reaction, exaggerating a pose, having this contrast between squash and stretch shapes. You can find a tutorial on how to animate a head take based on the squash and stretch principle and an exercise. Hope that these lessons help to well understand these awesome principles, so make a good use of it.